Hello and welcome to Algebra Unit 1-2, Lesson 3. Today's objective is scholars will interpret and compare linear functions. So we've written them, we've graphed them, now we are interpreting and comparing linear functions. So let's look through this. So 3 cars. 3 cars are traveling to the same campground along the same route. The cars began at the same place, but at different times. Car A began their trip at noon. I'm going to highlight that, at noon. So car A began the trip at noon. Cars B and C began the trip at different times before noon. The miles traveled by cars A, B, and C are represented respectively by the following graph, table, and equation. So let's take a look at these. So here I can see car A. I can see it started, this is time afternoon, it started right at noon. Then I can see car B, and wow, yeah, it definitely started before noon because otherwise there's no way in 1 hour it ended up 110 miles down the road. And then, of course, I have car C, which has an equation where D represents the distance and T represents the time. Okay, so time and distance. So, we've got this situation. Now we have a question. At what time, if ever, will car A pass the other cars? Describe any assumptions you make to justify your answer. Okay. So we need to figure out if car A is ever going to pass the other cars. So, one of the easiest ways to do this is to put them all into the same format. It is hard to compare a graph to a table to an equation. It is easier to put them all in the same format. So I'm going to put them all into a table. So you can see I already have on here car B because it was already in a table. But I've got a spot for car A and a spot for car C. So, car A, I'm looking at this graph down here in the bottom. And I can sort of make it bigger so we can see it a little bit. When you're looking at the graph, we're going to look for a spot where it touches exactly on the graph. So in this case, it looks like if I look at this point right here, it looks like it hits exactly on where these lines cross. So I'm going to use that point. Now I'm going to check to see what that point means. That point says 5 hours after noon, car A was 350 miles. Okay. So on my graph, or on my table, make this back down so we can see the whole thing again. I know that car A at 5 hours was 350 miles. And I can see that this is a proportional relationship because I start at the origin at 0, 0. So that means I can find my rate of change here by just dividing 350 by 5, which tells me it's going 70 miles per hour. So that means at 1 hour it was 70 miles. At 2 hours it was 140 miles. At 3 hours it was 210 miles. At 4 hours it was 280 miles. And it keeps going. Okay, so now let's look at car C. Car C, we have an equation. We're really just going to put a 1 in for time and figure out what that is. In this case, we put a 1 in for time and we get out 88. If we put in a 2 for time, we get out 156. If we put in a 3, we get 224. And I'm just doing this with my calculator. If we put in a 4, we get 292. And if we put in a 5, we get 360. Okay? So, We've filled in our table. Now let's look at how we can answer the question. So, at what time, if ever, notice that if ever, will car A pass each of the other cars? Well, first, I know that car A was traveling 70 miles per hour, right? Miles per hour, yeah. Okay, I know car C from the equation was traveling 68 miles per hour. And car B, I can figure out its miles per hour by simply going change in Y. So this increases by 65 per hour. So this is going at 65 miles per hour. So I can see that car A is definitely going faster. That means that eventually car A must pass cars B and C. Well, I could just continue my table and see when it passes them. And I could get the hours. So let's talk about what our assumptions would be. We assume, so let's talk about our assumptions. We assume that they're traveling at a constant rate. So we're assuming a constant rate and no stops. Because, when you drive, sometimes you make stops. So we're assuming a constant rate and no stops. Although, of course, we all know sometimes you have to stop for things like gas. So we have to assume those things. So those are our assumptions. But I can tell you that I would pass, if I extend my table, I can see that car A would pass car B. Notice there is a 5 mile per hour difference in their speeds. And right now there is a 20-mile difference between the two cars. So that would take another 4 hours to catch up. So that would be at 9 hours. So I'd pass car B, sorry, after 9 hours. There is a 2 mile per hour difference between car A and car C. And right now they are 10 miles apart. So that would be another 5 hours. So I would pass car C at 10 hours. Okay? So go ahead and play around with this. You can extend your table if you want and keep going. But make sure that you get all of your assumptions and think about how you would do it. Okay, I will see you in class if you have any questions.